Hey, any of you guys do this week's physics module? I'm kind of having some trouble.
I'm still on the kinematics module from the first week, and I have to tell Sarah that I need to MSAF both my midterms.
Yeah, I should probably do that soon. What about you, Kevin?
I'd help you, but I don't get it myself. I think the best thing to do is go to Sarah's office hours. She is the best professor after all.
You're right about the office hours, but I think I'm going to Dr. Chen's instead. He's clearly better than Sarah.
Excuse me, Kari is clearly the best prof.
How would you know that? You haven't been to class since the first week of school.
I mean, he has the best fashion sense, so.
No, I think Chen does.
No, Sarah's definitely the best.
No, Kari is.
Alright, the only way to settle this is if we have a shopping cart duel.
Challenge accepted.
I was never that invested, so I'll come along, but I'm just gonna watch.
Go. Go.
So now we're going to determine the winner of the contest. And in order to do that, we have to see who had the greatest final velocity after the collision. But we can't find the greatest final velocity until we find the constant velocity that they were traveling at before the collision occurred. So to do this, we used Fermi to estimate the displacement that each boy traveled, and we used the parking space width that they traveled across, and one parking space is approximately 2.5 meters wide. Kevin's acceleration occurred across 3.75 meters, which was about 1.5 parking spaces, and he was able to do this in 1.8 seconds, which we determined using a timer. So over this distance he was accelerating, which is 3.75 meters for 1.8 seconds, and then following that prior to the collision he had a constant velocity. We are going to use the equation delta x is equal to is equal to initial velocity plus final velocity divided by 2 times time in order to determine what the final velocity is. And we're using this equation because we don't know what the acceleration is, but we do have each of these values. So with the initial velocity equal to 0 meters per second, let's plug all of this into the equation. And in doing so, we find that the final velocity Kevin traveled at was 4.17 meters per second. And using the exact same method for parts displacement and velocity, we find that his final velocity is 3.08 meters per second.
Alright, so now that we know the constant velocity with which both boys are traveling at before the collision occurs, we can determine the combined final velocity after the collision has happened using the law of conservation of momentum. To do this, we must first determine the initial momentum, which is simply equal to my mass plus my shopping cart's mass times our combined velocity plus part's mass plus his shopping cart's mass times their combined velocity. Because part is initially at rest in my collision where I'm in motion, the initial momentum is simply going to equal to my momentum, which turns out to be 417 kilograms times meters per second, but because it's mass times velocity. And then we can use the law of conservation of momentum to determine final momentum. We know that final momentum is going to be equal to the combined mass of my mass plus part's mass plus our 2 shopping carts times our combined final velocity. We also know that the final momentum is equal to 417 kilograms times meters per second. Once we equate those two equations, we can determine the final velocity to be 2.19 meters per second, since we already were given the final momentum and the masses earlier. We can do the same methodology to determine part's final velocity after doing the same thing that we did on this side, and that turns out to be 1.46 meters per second. Because my final velocity was greater than part's, we can determine that I clearly won the duel.
So although you won the shopping cart duel, Kevin, you forgot one important aspect, that's a perfectly inelastic collision. Now to determine the initial kinetic energy, use the formula half mv squared. Now since I'm at rest, my kinetic energy is 0 at initial. So half times 100 kilograms, which is his mass with the shopping cart, times the constant velocity, we can see that his initial kinetic energy is 869.4 joules. Now to find the kinetic energy final, you basically use the same formula, but you use the combined mass of me, Kevin, and the shopping carts, and the velocity after collision, which we see is 455.6 joules. Now we can see in this situation that the kinetic energy is going down, and when we use the kinetic energy to find my initial and my final, kinetic energy is also going down. This is due to external forces such as friction. Now we know that momentum is conserved, kinetic energy isn't conserved, and we're both moving at the same velocity since we're part of the same unit, which are all characteristics of perfect inelastic collision.